My name is Joshua Rafael Justin, and I'm from Kota Marudu, Sabah.
I'm Corinne Ho from Group 7.
Hello everyone, my name is Karen and I'm from Group 7.
So for today's video, we're gonna learn about finding inverse matrices using adjoint method. The adjoint of a square matrix A is the transpose of cofactor matrix, which can be obtained by interchanging every element Aij with the cofactor Cij and denoted as adjoint equal in bracket Cij power t equal in bracket Cij. If A is not equal to 0, then A inverse exists. Therefore, the inverse matrix is like this.
Now we will continue with example 7.12, which is to calculate the inverse of the following matrix. So the first step, we will calculate the determinant of A. We will find the cofactors by using the cofactor expansion, which we have learned before. So for C31, the minor M31 equals to 2, 1, negative 6, 3. We get it from here. Row 3 and column 1, this part. So for C32, our minor is M32, which is equals to 4, 1, negative 2, 3. For C33, our minor M33 equals to 4, 2, negative 2, negative 6. So our determinant of A equals to negative 7, negative 1 to the power of 3 plus 1 multiplied by M31 plus 5 multiplied by negative 1 to the power of 3 plus 2 multiplied by M32 plus 0 multiplied by negative 1 to the power of 3 plus 3 multiplied by M33. Then our final answer for the determinant of A is negative 154. And since it does not equals to 0, we can continue to find the cofactor matrix at step 2. The cofactor matrix is basically just follow the formula we've learned before, which is Cij equals to negative 1 to the power of I plus j multiplied by Mij. So, for example, cofactor C11, which is to cross out row 1 and column 1, we will get this part for our minor, our M11. And this one is basically just negative 1 to the power of 1 plus 1, we will get 2. Then for C12, we just cross out row 1 and column 2. Then we will get this part here. And this one is negative 1 to the power of 1 plus 2. And we will get 3 here. Then we will continue for C13. And we will calculate the cofactor for the rest of the element in the matrix. And we will get, for example, the first element in our cofactor matrix is this, the first cofactor we calculated, and the second one, negative 21 is the second, and so on.
Hello everyone, my name is Karen and I'm going to continue step 3 and step 4. So previously we have obtained the cofactor matrix, which is this one. So now, in order to determine the adjoints of A, we will have to find the transpose of the cofactor matrix. So in order to find the transpose, we will interchange the rows and columns. So by simply changing the first row into the first column, which is this one, and the second row to second column, and same goes to third row, will become the third column over here. Okay, so after doing this, we will now obtain the adjoints of A. So since we have the adjoints of A, which is this one, and also the determinant of A, which we already obtained previously, which is determinant of A equals to negative 154. Okay. So in order to find the inverse matrix of A, we can now use the formula, which is equals to 1 over determinant of A times the adjoint of A, which is this one. So we can now sub the value into the formula, which is shown here, 1 over negative 154, which is the A determinant, and we now times together with the adjoint of A, which we obtained previously by simply transposing the cofactor matrix. Okay, so the inverse matrix of A also can be written as you times in the value over here, so each of the value in the matrix. So which is equals to 15 over 154, 5 over 154, all this negative over here, and so on. Then goes to the other value. Okay, so by doing this, we have already done, and we will be able to determine the inverse matrix of A. So that's all from our group. Thank you.